Hello again. All right. So this video, we are going to, we're going to derive the product rule. In other words, the derivative of a product. And what I'm going to do is I'm actually going to state the result first. Okay? And it looks like this. The derivative of two functions being multiplied together, f times g, is the following. Okay? It's the derivative of the first piece times the second piece with no derivative plus the first piece with no derivative, and then the derivative of the second piece. Okay, so we add the contribution of change from each function being multiplied individually. Okay, so that's the result, and let's go through the proof. And then in the next video, we'll do some examples. Okay? So here we go. All right. So suppose we have a here we go. I'm doing this h thing again. Let's not use h. Let's use p for product, right? Suppose p equals f times g. Okay, so if this is the case, then the derivative of p is the limit as h approaches 0 of the following: p at x plus h minus p at x over h. Okay? And just like we've done before, we need p at x plus h. And just by substituting that in, that's just going to be f at x plus h times g at x plus h. So let's plug everything in and see what happens. Okay, p at x plus h. Well, we just calculated that. That's f at x plus h, g at x plus h, minus, and then p is f of x, g of x, being multiplied over h. Okay, cool. That's not very useful. So what can we do, right? Let's get a little more technical, and let's talk about sort of the goal here. Okay, the goal is to write the product in terms of f and g. Okay, so here's what I'm saying. The derivative of f is this. The derivative of g is this. There we go. There's the expressions for the derivatives of f and g. We want to basically use these expressions here. But as this is currently written here in green, we don't have any of these expressions. So we have to be clever. Okay? And the thing that we're going to do to the green expression is we're going to add 0. Okay? Here's what I'm saying. First, h approaches 0, and then we get f at x plus h, g at x plus h, minus f at x, g at x, plus 0 over h. Okay. Now, the 0 that we're going to add is the following. Basically the cross term. G at x, f at x plus h. Sorry, let me try that again. And actually, you know what? I'm going to do it the other way. I'm going to do f at x, g at x plus h, minus f at x, g at x plus h. We should all be able to agree that f at x, g at x plus h minus itself is 0. So wherever I see 0, I'm going to substitute this expression in. F at x, g at x plus h minus itself. Okay? So if I do that, I wind up with the following. And again, I'm going to add f at x, g at x plus h, minus f at x, g at x plus h, minus f at x, g at x, all over h. Okay, and now what I'm going to do is I'm going to look at this. I'm going to see if I can factor. And the first two terms contain g at x plus h. But okay. And I also want subtraction because I want subtraction because I'm trying to use the individual derivatives that I have here in this weird color, this orangish reddish thing. Okay, so what I'm actually going to do is I'm actually going to group these terms together. I'm going to look at term 1 and term 3 together, and then I'm going to look at term 2 and term 4 together. Okay, so if we look at 1 and 3, 1 and 3 both have g at x plus h. If I factor g at x plus h from term 1, I'm left with f at x plus h. And if I factor this from term 3, I have minus f of x. Okay, and just like I did before, I'm going to put the h in a couple different places. All right, cool. So there's that. But now what about the other two terms? So we have plus, and again, let's look at term 2 and 4. Term 2 and 4 both contain f of x. And if I factor f of x, I'm left with g at x plus h minus g of x, and then over h. H is dividing everything. Okay. All right. Cool. Okay, good. Everything's good. Okay. So now let's look at this expression. F of x plus h minus f of x over h, limit h approaches 0. Okay, so this is literally df dx. And now let's look at term number 2. g of x plus h minus g of x divided by h, limit h approaches 0. So this is dg dx. All right, cool. So essentially what we have is this, right? Limit h approaches 0 of the following. G at x plus h times df dx. And by the way, by doing this, we get rid of both h's. Plus f of x times dg dx. And now, if we do the limit as h approaches 0, g at x plus h becomes nothing more than g at x. So we get g of x df dx plus f of x dg dx, which we can write like this: g of x f prime plus f g prime at x, which is what I stated up here. F prime g plus f g prime. F prime g plus f g prime. There we go. Right? So there we go. There is the proof of the product rule. Awesome. So we'll do some examples next time.